Welcome. Today, let's explore advanced techniques for debugging shell scripts. We will equip you with the knowledge and tools to tackle even the most challenging script issues. The topic of the day is advanced script debugging, techniques for debugging shell scripts. So let's begin. Let's start with the debugging fundamentals. On the left are common debugging methods and on the right, essential debugging tools. Common debugging methods include print debugging with echo statements, tracing script execution with set-x, verbose mode with set-v, error handling with set-e, step-by-step execution, and log file analysis. Essential debugging tools include ShellCheck, which is a static analysis tool, Bash-n for syntax checking, Bash-x for execution tracing, Trap for debug signal handling, Logger for system logging, and custom debug functions. Now let's learn about tracing script execution. The set-x option enables execution tracing, displaying each command with expanded variables before execution. This is one of the most powerful debugging techniques. Here's an example. After the shebang, we enable tracing for the entire script using the command set-x. Then we assign world to the variable name. Next, we print hello $name! Moving on, we can also enable tracing for a specific section of the code. Set+x disables tracing, so the echo command that follows won't be traced. Finally, set-x re-enables tracing, so the final echo command will be traced. Custom debug functions allow for controlled and formatted debugging output that can be easily enabled or disabled. Here's how you can create one. The example shows a debug function with severity levels. First, we define a function called debug. Inside the function, we set the debug level to 0 if it's not already set. The function takes two parameters, level and message. The if statement checks if the level is less than or equal to the debug level. If it is, the message is printed to standard error, prefixed with debug. Finally, there are example usages of the debug function. First, we set the debug level to 2. Then, we call the debug function with different levels. The message with level 3 won't be displayed because the debug level is set to 2. Let's explore error handling techniques. On the left, we have set options for error detection. Using Bash's set options to catch errors early and prevent script execution with unhandled errors. Here's an example. After the shebang, we enable exit on error with set-e, exit on undefined variables with set-u, and exit if any command in a pipe fails with set-o pipefail. The last line shows a common combination of these options, set-uo pipefail. On the right, we have using trap for error handling. The trap command allows you to catch signals and execute code when errors occur. The code shows the usage of trap command. First, we define a cleanup function that prints an error message including the line number where the error occurred and removes temporary files. Then we use the trap command to call the cleanup function when an error occurs. The error signal is triggered when a command exits with a non-zero status. Finally, we use trap to print a message when the script exits using the exit signal. ShellCheck is a static analysis tool that gives warnings and suggestions for Bash or sh shell scripts. It helps identify syntax errors, semantic issues, and potential bugs. The example shows a script with issues. The variable file name is assigned the value of the first command line argument. The if statement checks if the file name is equal to data.txt. If it is, the cat command is used to print the contents of the file. ShellCheck will suggest double quote $file name to prevent globbing and word splitting. Use double square brackets instead of square brackets for better compatibility. Running ShellCheck. Install with your package manager and run with ShellCheck script as it can be integrated with most code editors and CI or CD pipelines for automated checking. Here we have advanced debugging techniques. On the left, customizing debug output. Enhance your debug output with timestamps, line numbers, and function names for better context. The example code shows the debug function. The timestamp variable is assigned the current time. The func variable is assigned the name of the calling function. The linino variable is assigned the line number where the debug function is called. The printf command prints the timestamp, function name, line number, and the debug message to standard error. On the right, debugging techniques for functions. Use funcName array to track function call stack. Add debug entry or exit points to complex functions. Test functions in isolation with test harnesses. Use declare-p to inspect variables. Implement function-level debug flags. The example code shows the process file function. When the function is entered and exited, the message is printed to standard output. Also, declare-p is used to print all variables. Let's learn about conditional debugging. Implement conditional debugging that can be enabled or disabled without modifying the script code. The example code shows how to enable debugging with an environment variable. If the debug environment variable is set to 1, set-x is executed, enabling tracing. Next, we create a debug function that checks the debug level. If the debug environment variable is greater than or equal to 1, the message is printed to standard error. Finally, the example demonstrates how to use the debug function and normal echo command. This allows specific debugging outputs to be toggled on or off based on the debug environment variable, maintaining clean code and controlled debugging output. Here are the debugging best practices. On the left, we have the script structure. Use functions for modular code. Implement proper error handling. Add --help and --debug flags. Follow consistent naming conventions. Comment complex logic and algorithms. On the right, we have the debugging workflow. Start with syntax checking --n. Use ShellCheck for static analysis. Add strategic debug statements. Test with sample data and edge cases. Document debugging techniques in comments. Thank you. Any questions? If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.